My name is Bockhorst. I'm working in another division called DPD, the Developer Products Division, that is dealing with Intel tools. And the following presentation was compiled to a great extent by a colleague who delivered these system tips to the Marconi cluster people. And they claimed that they had some advantage from some of the settings. So I will just show it to you. And for most of you, I think these tips will not be really relevant. But for those who are probably digging a bit deeper and using others than Cray KNL clusters can probably profit from these system tips. So the outline would be the XPPSL. This is the Xeon Phi processor system software layer, and which is the extension of the normal kernels you have, and software. Then some settings and getting the memory and cluster modes. How you can do it, more something for system administrators than ordinary users, but probably nice to know. Linux configuration, supporting performance analysis, user level M-weight. I'm not sure if this can be really exploited by you, but probably nice to know that there is something available like this. And last but not least, I would like to promote a little bit another tool from Intel that's called Cluster Checker. And Cluster Checker is provided in the Cluster Studio. Probably not necessary here on your Cray system, but you can use and configure this to validate and test cluster configurations. So you can it's very easy to run and analyze the data, and you can just give it a try and see it. It will automatically test for you all the stream benchmarks and the HPL and so on, and will check and compare with archive data if it's in the interval that's acceptable, or if it has to be validated that there are probably errors in the configuration. Yes, the XPPSL is just an add-on for the usual distributions and the stuff that's not upstreamed yet. And we have then more functionality in advance to that. So it comprises the new kernels or updated kernels, a tool called CPU power to measure the power, and other CPU stuff. Turbostat is similar, which can show you the turbo mode and the turbo frequencies. MikePerf is a performance suite where you get some of the benchmarks that are crucial to test the performance of your system. And then some things about memkind, CPU, ID, HW lock, and MCE lock, and so forth. So CPU power, you can try it if you have installed the XPPSL, and this can show you what is the current frequency should be in this interval, and this is after you have set that the only non-turbo frequency is equal to the max frequency. So you just have 1.4 gigahertz available. This is probably for the performance the best, but I don't know what our friends from Green Computing say to this. So you're just using the max frequency here. And here are two settings for system administrators to change the turbo state and the frequency. Turbostat is a tool that looks a little bit like TOP, but with different content, and it's updated frequently, so you can see how the system states are changing, and it shows you the frequency changes, the idle states, the watts consumed, and some other system specific features. So here is an example of turbostat, and you see here are the turbo frequencies or the measured frequencies, and you see here we are above the defined non-turbo frequency of 1.4. This is the reference here, it's all around 1.4 gigahertz. Then there are some other interesting stuff like the watts consumed by the RAM and the watts consumed by the package. And there should be also, it's not shown here, but a column for the core watts. Yeah, and some, what else? Yeah, and probably here the temperatures are interesting as well to see. In case that your heat management doesn't work correctly. So this is the, to compare it with the previous slide. On the previous slide, we saw that there are frequencies above the 1.4 gigahertz, but here you see in the column of the frequency only frequency up to 1.4 gigahertz because turbo is here disabled. So you can check here that turbo is really disabled. MikePerf is a collection of performance benchmarks for Mike, and it's the usual suspects like DJAM, Stream, LinPack, and HPCG, and we have pre-compiled binaries, optimized binaries, for example, and with some built-in run recipes. So it's all quite convenient. So you have a starting script like Mike prun, and then you can give it some parameters here to run the stream benchmarks or to run DJAM with certain metric sizes. So that's quite convenient. And in the end, you have a plotting tool to get nicer output. So BIOS consideration, that's how more interesting for the administrators and probably not for Cray administrators, but this is how you, in principle, can change the memory mode and the cluster mode here with these sysconfig calls. And then you don't need only to reboot the system after changing it, but also power cycling it. It's probably the power cycling probably changes in the future, but I'm not aware of it now. Here's a little script to directly get the mode you are in currently. So if you download the tool here and compile it, it tells you that you are currently in current mode and memory mode flat. Linux configuration. So about the linker and library mapping, about the zone sort module that Hans was talking about before. But these are all very advanced options that you might check if any other optimizations didn't work for you. Using large pages, the tickless kernel configuration, I saw that there is something similar available on Cray systems and other stuff. So the linker, so on Cray systems, anyhow, the default would be more static linking. But if you have, if you are using dynamic linking, then you might try to use or install this linker patch and try the this variable here to get an optimized linkage of your program. The zone sort module, yeah, it should be also part of the XPPSL, and you can load it. Then you can, what Hans also talking about before, clear the caches. Oh, sorry, clear caches and trigger memory compaction. So this tries to optimize the memory layout for your program. And yeah, as I said before, this is quite an advanced way of improving this dynamic linked executables. Also, the use of huge pages, I saw it's also integrated into the Cray software as well, but here are some information about how to use the huge pages, like how to disable the transparent huge tables by piping never into this parameter here, into this file of the this kernel file system. Or you can check if it's enabled by reading this file here from the kernel file system. So probably not too interesting for most of you. And faster than the transparent huge pages are the explicit pages that can be set similarly. So let's go further. The Linux tickless configuration, I think that was brought even some advantage on the Marconi cluster when they did this. But I think in the Cray environment, it's also integrated a similar thing, like it's called core spec. The idea here is to reserve one core or one tile for the operating system, that all the system ticks and so on will happen on the first tile, and your application runs on the rest of the tiles to separate the influence of the OS from your application. And this could be really a performance changer. So here it's written it's in the range of 5%, but I've seen a Cray presentation where they've shown MPI calls, collective MPI operations with one rank per node, and this can be crucially influenced by this core spec or this tickless stuff by removing the fluctuations from the OS. So they claiming that they see sometimes 5x differences between tickless and non-tickless. So this is something really to consider, and when you are using the Cray system, it may be much easier than this settings here to realize it from user space. So this is something really to consider if the tickless configuration can be valuable for you. Some other Linux consideration, like disabling the NUMA balancing and you should avoid unnecessary services. So I was 2 weeks ago on a KNL workshop in Bologna, and they were reporting about their system, and one guy has measured the differences in performance per node on the Broadwell cluster and then comparing it with the KNL cluster. And the KNL cluster had a much broader variety of performances. So the variation of performances from node to node in the measurements was much larger than on the Broadwell system. That is probably an indication that every unnecessary service and every unnecessary disturbance will have a much higher impact on the KNL system than on the Broadwell or on the mainline Xeon system, and you should really try to avoid all that. Unexpected MCD-RAM interactions. So you've seen already this from Hans, these parameters that you have NUMA CTL, and then you can use either minus P or either minus M. Minus P is preferred, so everything here will be first allocated inside NUMA node number 1, which is the MCD-RAM in flat mode, and the rest should be partially allocated on DDR. NUMA CTL minus M1. If you have enough memory here for your application, then it should work like expected. But when the memory exceeds the MCD-RAM, my colleague has written it will swap, but I will more guess that it will crash if you exceed the MCD-RAM. So you should really try to avoid this. And NUMA CTL minus P0 is that you probably take this if you want to get all the memory. So you get by default the DDR memory, and when it's full, it will partially allocate on MCD-RAM. But this is rather seldom, I would say, that people would do that. I would rather think that the first two will be what you need, and probably if you go further into the analysis of your program, then you try to explicitly allocate in the MCD-RAM the important arrays. I will tomorrow probably show one slide about what vTune can do for you to see which kind of arrays you can or should allocate inside MCD-RAM. So how to control hardware prefetches. So these are some more for administrators as well. So you have a tool where you can, with certain bits here, you can influence how the prefetches work if you want to have both prefetches for L1 and L2, or if you will only want L1 or L2. So this is something more for the administrators, and this here, I think it's more informative as well. So I don't know how you can really profit from that, but it's just to see that something like this is available. So there's additional ISR here to monitor logical addresses and memory changes that can help to improve other libraries like OpenMP, pthreads, MPI, and so on. So coming to an end, I would like to make a little bit advertisement here for the Intel Cluster Checker, because I worked closely with some of the guys from this group before, and it's probably very hard for them to sell this to other system manufacturing, to other companies like Cray or IBM, because they have their own tools and their own chain of how to build systems. But you can, even from user space, you can use this tool to validate or analyze your system. So there is, it's easy to run. So it's just that you run this tool on a subset of nodes. You give it a node file. You can run this tool with one simple command on the nodes that you specify, and then it will give us some results. And then there's a second phase from analysis that will provide some comments on the results of that. And it's all steered by, it can be even run by non-root users. It's designed by experts. Contains similar tests and benchmarks like shown before. So all these linpack and stream benchmarks are comprised here, but probably can be done in an easier way by having all this framework, and which is steered by flags and XML files that you can change. And there's even this Scalable System Frameworks SSF initiative, if you like to see what this is, and to the idea is there since 10 or 15 years that we want to have a tool to validate systems. What is a very hard target, but they are still trying and have some kind of compliance with this standard setup of clusters that they want to check with the cluster checker. So you probably already have it. If you have the Parallel Studio Cluster Edition, it's one part of it, so everybody can use it. One picture I've stolen, so here we have the compute names, nodes, let it run, and gets a data collection into a database. And then you have this knowledge base that can be used by another command line tool to get the results of your previous tests. Common job requests. What if you make a job, then you have to specify the memory node mode, the cluster mode, the turbo mode, the frequency, and probably the prefetches. And some suggested default job settings that we just set the max frequency. Okay, that's pretty obvious if you want maximum performance, but probably not good for the energy consumption. Enable turbo, clear the buffer caches probably, and compact memory, sort the pages, restrict to the this kind here with the tickless kernel. Sanity checks, either with this micperf, or as I said before, the cluster checker can do the same for you. And so on our own clusters, there's sometimes annoying, they always run stream in front of every batch job to check if the nodes are okay, which can be annoying, but probably good if you really want to benchmark and sort out nodes that are not working properly. So, do you have any questions to that? Probably not because of the lunch.
No questions? All right. So thank you. Thank you very much for you. So we'll then have lunch. We'll be here, and so it's 1 hour lunch. So at 1 o'clock we'll come back here.
And other CPU stuff. Turbostat is similar, which can show you the turbo mode and the turbo frequencies. MikePerf is a performance suite where you get some of the benchmarks that are crucial to test the performance of your system. And then some things about memkind, CPU, ID, HW lock, and MCE lock, and so forth. So CPU power, you can try it if you have installed the XPP-SL, and this can show you what is the current frequency should be and so on, and will check and compare with archive data if it's in the interval that's acceptable, or if it's it has to be validated that there are probably errors in the configuration. Yes, the XPP-SL is just an add-on for the usual distributions and the stuff that's not upstreamed yet. And we have then more functionality in advance to that. So it comprises the new kernels or updated kernels, a tool called CPU power to measure the power and my name is Heinrich Bockhorst. I'm working in another division called DPD, the Developer Products Division, that is dealing with Intel tools. And the following presentation was compiled to a great extent by a colleague who delivered these system tips to the Marconi cluster people. And they claimed that they had some advantage from some of the settings. So I will just show it to you, and for most of you, I think these tips will not be really relevant, but for those who are probably digging a bit deeper, and I'm not sure if this can be really exploited by you, but probably nice to know that there is something available like this. And last but not least, I would like to promote a little bit another tool from Intel that's called Cluster Checker. And Cluster Checker is provided in the Cluster Studio. Probably not necessary here on your Cray system, but you can use and configure this to validate and test cluster configurations. So you can, it's very easy to run and analyze the data, and you can just give it a try and see it. It will automatically test for you all the stream benchmarks and the HPL, and using others than Cray KNL clusters can probably profit from these system tips. So the outline would be the XPP-SL. This is the Xeon Phi processor system software layer, and which is the extension of the normal kernels you have, and software, then some settings and getting the memory and cluster modes. How you can do it, more something for system administrators than ordinary users, but probably nice to know. Linux configuration, supporting performance analysis, user level M